Alright gang, we're going to wrap up chapter 9 here. So, when you create an array, its values are initialized to 0 when you actually allocate it with a new command. Or the variance of 0, right? Floating point gets 0.0. Boolean gets false, and references, like strings, get null. So if you create an array of strings, you're really just creating an array of string references. If you say, I want an array of strings and it's 10 long, you get 10 nulls in a row that you can later actually fill in with string values if you want. So you can use the .length property to find out how many elements are in the array. And we've been doing this, right? Colors.length. Well, in this particular case, there are 5 elements in that array, so colors.length is 5. And so when we count from I0, I less than 5, I++, we can print out all the elements of the array for subscript 0 through 4. Partially filled arrays. A partially filled array is when you use some of an array's elements, but not all. If you have a partially filled array, you have to keep track of the number of filled elements in the array so that you know how to process those differently from the non-filled elements. Like you're trying to keep track of test scores, and the student has only taken 3 tests. It's not fair to tell him he only has a 30% average, even if he got 100 on all of them, because you're treating them like all of them are active when only really 3 of them are active. So in the contact list 2 program, note how filled elements vary. No, why don't we write our own? That's more fun. I believe we're on lecture X. Or is it lecture Y? Doesn't much matter. I think I'll just call it lecture Y, and if it turns out to be the wrong one, then whatever. All right, so we're going to make a partially filled array. It's going to be an array of names, right? So string names equals new string 5. We can hold up to 5 names. Now let's make a scanner so we can do data entry into it. Add our import. All right. Let's let them start entering some data. So why don't we declare a variable? Int count is equal to 0. And then while count is less than the length of the names array, names.length, let's ask for a value, system.out.println, enter a name, or Q to quit. Right? If they type in Q, we actually do want to quit, right? So let's read the data in. String s is equal to sc.nextLine. And then let's check to see if it's Q. If s dot equals ignore case, parentheses, quote Q, and quote in parentheses, then we want to break, right? Don't want to keep entering data if they've typed in Q. Otherwise, we're going to store that in our names array. Names subscript count is equal to s. And let's print out our array, just so we can see what our array looks like, right? System.out.println arrays.toString names. We need to add the import for the arrays class. And why don't we also print out the count? Count equals end quote plus count plus a space and then arrays.toString names. I seem to have introduced some error by doing that. Oh, forgot my extra plus here. There we go. All right, let's run it. All right, it's going to say enter a name, right? My name is Bugs Bunny. There. Now the count is equal to 0, and I've made a mistake. What's that mistake? I never incremented count. Right, I need count plus plus in here. Let's stop that. And we just stick it right here, right? Or we can put it on its own line if that looks too clever. All right, enter a name. Bugs Bunny. All right, so here's what our names array looks like right now. Bugs is the first element, and the rest of them are still null. So if we tried to process this array in any meaningful sense, if we tried to print out names, we would be printing out null, and it would look pretty lousy. So we have to keep track of that counter variable. Now we should have incremented the counter variable before we printed it out. I should have left it where it was. I should have left it in that plus plus in the subscript. But all right, once more. Enter a name, Bugs. Enter a name, Daffy. All right, and so now the array has 2 names in it, and the count is equal to 2. So if we want to handle this loop, if we want to process this array, we need to use this counter to tell us how many valid elements we have, right? So we could go from I is equal to 0 and keep going while I is less than count. So I is equal to 0, I is equal to 1. Now we have count is equal to 2. And if we kept going, right? Sylvester the cat. 3 names in it. Tweety. Or is it Tweety? Whatever. 4 names in it. Foghorn Leghorn. 5 names in it, and we're done with our data entry, right? Any point up until then, I should not be accessing the entire array. I should only go up to count. So let's write another loop that does that, right? Use a for loop to display the data items entered using the count variable to tell us how many data valid items we have. So for int. Now why wouldn't we use a for each? Because for each is just going to go straight to the end, and so if we had nulls at the end of it, we would print those out. We don't want to do that, so we're going to use an index-based for loop starting at I, keep going while it's less than count. System.out.println name subscript I, right? So let's run it, but only enter 3 pieces of data before we enter Q, and make sure that this for loop only prints out 3 pieces of data. Right, so enter a name, Bob, Abe, Sam, and Q. All right, so the last we saw, our array had 3 strings in it and 2 nulls in it, and our count was 3. So when we chose quit, that's what the array looked like. That's the state of our data, and so we did I starting at 0, going up to but less than count, and so it printed out subscripts 0, 1, and 2. So that's an example of a partially filled array. Use a counter to indicate the position of the last valid element. The counter starts at 0 when no data has been entered, assigned to the array yet. copying an array. Didn't we talk about this? As with all arrays, if you assign one array reference variable to the other, they both reference the same memory. So if I created a names2 array and then I sorted it, the names array will also be sorted because there actually is only one name. It just has two names, just like a person could have two names, right? Or a street has two street signs pointing to it. So if you do this, you're just copying the memory address of array 1 into array 2. So if you're going to copy an array, and I know we talked about this, then you could either write your own method to do it, or you could use arrays.copy, right? Yeah, I know you did this. So we want to make a second array. Well, we could make an array that only had the correct number of items in it, right? This is different than the one that we were just talking about, but we could do string names2. We need our curly braces, our square braces to indicate that it's an array, equals new string, but how many do we want? This time we just want count, right? And we're going to use a loop just like this to copy the data elements into it. Now normally we would create this to the same length as the original array, right? I'm kind of combining two concepts. I'm combining the partially filled arrays and the copy arrays. So normally you allocate a new array to the desired length, which is usually the length of the original array if you're copying the complete array, and then copy the elements in. And normally we would go while I is less than names.count in order to get them all, but since it's a partially filled array, we're going to use that variable instead. And so names2 subscript I is equal to names subscript I. Like that. That's how you copy an array. Or we use one of the functions, right? See, it's probably telling us something, like we could replace this with a system.array copy. And sure enough, we can. And what are you complaining about? This array is only written 2. All right. So yeah, you could do that, right? Copy from the names array starting at position 0 into the names2 array starting at position 0. And this is how many elements. Okay, so or use systems.array copy, right? System.array copy. That's another way. Or use the arrays class. And I'd prefer to do that because it's syntax cleaner. Seems to me anyways, right? So names2 equals arrays.copy range. Okay, well, I guess we could just use copy of, right? And we're going to specify that we want to start with the names array, and we want to go out to that many variables, right? That many elements. I like this syntax better. Of course, this one's super flexible because you can specify what starting position. Well, I want to start copying this array from element 100, and I want you to put it into element 30 of the new array, and I want you to count out 15 of them, right? Really powerful. On the other hand, sometimes that's too many parameters. So I would do it like that if I was personally writing my own code here for professional purposes. Like that. Because otherwise, and I said this before, so I'll say it again, if you do something like this, again, I forgot to indicate that it was an array, and then you sort one of the arrays, right? Like that. Sorry, it's arrays.sort, isn't it? Arrays.sort the names3 array, and now we're going to print out the names2 array, and we're going to find out that it's sorted. System.out.println parentheses arrays.toString parentheses names2. And it's sorted as well because names3 and names2 are just different names for the same memory because we use the equal, the assignment operator, rather than doing one of these things. copying the elements in by hand, or using system array copy, or using arrays.copyf. Enter a name or Q to quit. Alrighty. Sam, Fred, and George, and Joe, shorter. Alright, now I'm going to quit. I'm tired of doing that. And there, see, when we sorted names 3, but printed out names 2, they are now in alphabetical order. Histograms. What's a histogram? It's a graph that displays quantities for a set of categories. It displays category quantities with bars. Shorter bars indicate smaller quantities. Longer bars equate to larger quantities, right? This is a histogram, right? Total U.S. cheese production in January. So I guess in the year 2002, we made that much cheese, and in 2003, we made that much, in 2004, we made that much, and so on. So let's use a random number generator and create a histogram of die rolls, because you probably know that if you have 2 dice and you roll them and add them together, 7 comes up more commonly than anything else. It's a bell curve, so-called bell curve, right? Just because there are more combinations that add up to 7 than anything else. There's only one combination that adds up to a 2 or a 12, and there's only 2 combinations that add up to a 3, right? This is the 2's column, the 3's column. There's 3 ways to add up to a 4. There's 4 ways to add up to a 5. There's 5 different combos that'll add up to a 6. And then there's 6 combos that'll add up to a 7. So let's make an array that'll hold our histogram data, and then make random number generator. And then we'll just roll dice like, I don't know, 100,000 times or 1,000,000 times or something. We'll count how many times each one is rolled. So we're definitely going to need the random class. So add import for java.util.random. So random RND is equal to new random, right? Now let's make our array of numbers. Now since 2 dice can roll a maximum of 12, I want 12 to be one of the values that I can type in, right? I want to be able to access all the way up to element 12, which means actually the array has to be 13 long, right? Because if it's linked 13, you can access elements 0 through 12. Now you may see something weird about that because we can never roll a 0 or a 1, but let's ignore that just for the simplicity of the algorithm, right? So int rolls is equal to new int, and we want 13, so that we can count whole numbers 2 through 12 at their subscripts, right? And we will ignore 0 and 1 when we print it out. We'll always start our counter at 2. All right, we need some kind of counter going for int I is equal to 0, I is less than 100,000. 5 zeros there. Semicolon I++. Now let's get our random dice rolls. Int D1 is equal to rnd.next int parentheses 6 end parentheses +1. That'll make a number between 1 and 6. Why will it be between 1 and 6? Well, because this actually generates a number between 0 and 5. The upper bound is not inclusive, right? It's exclusive. So this can go 0 to 5, so we add 1 to it to make it 1 to 6. The same business here. Let's make this say D2. And then our total, of course, is D1 plus D2, right? And let's store that into our array using this as our subscript. So rolls subscript total plus plus, right? Add 1 to the element at that position. And then when we're done, let's just print that array out, but starting at position 2. I mean, we could start at 0, but it's not going to have any good data there, right? For int I is equal to 0, I is the length of the rolls array. So rolls.length, semicolon I++, with system.out.println dice roll %d. If we're going to use these, we have to use %f. I mean printf equals %d for the count. And so I represents the number that was rolled in the histogram, and then rolls subscript I indicates how many times it was rolled. And then we can go, oh, it's going to ask me this stuff about names every time. I'm just going to do Q. All right, and so here we go. Right, we don't care about the number of times we rolled 0 or 1, because if you're rolling 2 dice, you can never get those values. So from now on, we're going to start at 2. But we rolled a 2 that many times, a 3 that many times, a 4 that many, a 5, a 6, and a 7, and an 8, and a 9, right? And so we can see that the 7 was rolled more often than anything else. And what if we wanted to turn that into some kind of chart where we printed out asterisks? Well, I don't know. 20 asterisks being the max, we could say. Well, how are we going to do that? We need to turn these into percentages. We need to find out which of these numbers is the highest. So we're going to write some code that'll go through it and find the maximum value, right? Actually, we're going to set this equal to the lowest value in the array. That's the correct way to do it in case you're dealing with negative numbers. We're not, but we could be. So we're setting our max counter equal to the lowest value of the array. And then we're going to do this for int v colon rolls for every value in rolls. If v is greater than the max, oops, I almost wrote Python there, then the max is equal to v, right? We just check every number we wrote, every number in the array. If it's greater than our max, we make it our new max. So when we print this out, we could print it out as a percentage instead, right? We can multiply the roll times 100 and divide it by the max, and that would give us the percentage. Q. All right, so right, if 7 is the highest, and we treat that like as 100% of the number of asterisks we want to print, then we're kind of seeing our bar graph here. And we could use a for loop to print asterisks out. For int I is equal to 0, I is less than. This is going to take a doubly nested loop, actually. Why am I saying that? Because to print the asterisks out, that's going to be the inner loop so that we can print 1 asterisk per value. And then the outer loop is going to increment our index counter so that we can go 2 all the way to 12. So we're going to copy this. But we're going to make a few changes. Let's just tuck this away here, store this here, and then say int stars equals that many, right? Because that's how many stars we want to print. And printf is only going to print out %d, which is this number here, right? Our index counter, the one that goes from 2 to 12. And then after that, we're going to have a for loop to print out asterisks. System dot, what? I said a for loop. For int I, no wait, we've already used I. X is equal to 0, X is less than the number of stars, X plus plus. System.out.print, not print line, because we don't want to go to the next line after every asterisk we print. Only when we're done printing out an entire row do we want to. So now it's okay to print a new line. All right, so this is going to print our number out, right? 2 or 3 or 4, and then this is going to print a row of asterisks after it. Quit. All right, and here we go. Here's our bell curve. If that's scaled too high, we don't have to multiply it by 100 before we divide it. We can multiply it by 50, right, to make the scale shorter. But anyways, you get the idea. There's our bar graph of our bell curve histogram. It might be nice to actually print the real values here as well as the bar graph, right? Guess we could. We could put a space and then followed by the number. So before we print the end of our line, system.out.println a space followed by roll subscript I. And now we'll see what that looks like. Probably look like garbage. Let's take a look. Well, we got 2 print lines in a row, but you get the idea, right? We rolled 2 2760 times, we rolled a 3 5700 times, and so on. Let's take out that second print line and we will be done. That. All right, so far I think we've been dealing with one-dimensional arrays. I don't think we did two-dimensional arrays last lecture. So what is a two-dimensional array? Well, it's like a spreadsheet, right? You have rows and columns. Or you have a tic-tac-toe board and it has 3 rows and 3 columns, right? So string but it's a two-dimensional array, so we need 2 pairs of braces. I'm going to call it tic-tac-toe is equal to, and we're going to initialize it in a funny way, just because. Each row of this double is its own array. And I'm not typing very well. Come up here. And since a tic-tac-toe board has 3 rows in it, we need 3, I did it again, 3 pairs of curly braces and the initializers. And each curly brace also has 3 values. And to initialize it, we're just going to initialize it with 3 elements that are spaces. And considering my typing is not up to snuff at the moment, I'm going to do that. Okay, so you can see it's an array of arrays. Now, did we have to space it out like that? We could have put it all in one row, right? Or we could have, I'm going to call it tick2, done this, equals new string. Now it's a 3 by 3 array, but we would have to have a loop that would set them all equal to spaces, right? Because right now they're all nulls. So it would look like this, right? For, why did I type a cap there? Int I is equal to, except now to print out a two-dimensional array, you need a nested loop. 2D arrays are processed with nested loops. The outer loop increments a row counter, and the inner loop increments a column counter so that you can deal with that element or that element or that element. So for int row is equal to 0, row is less than the length of the tick2 array. So tick2.length and a row plus plus. Now we have to do the same for the column. Now tick2.length or tic-tac-toe.length would be 3. It's not going to return 9. There are 9 elements here, but if you ask for the length of tic-tac-toe, it's going to say that it's 3 long. But we also need to know the number of columns, because that's going to drive the inner. For int call is equal to 0, call is less than tick2 at that specific row dot length, right? Because row zero's length is 3, row 1's length is 3, and row 2's length is 3. But it didn't have to be. We could actually make one that was 4. That's called a jagged array, right? So when they're not all the elements have the same length, all rows have the same length, they have different number of columns. But that's not the case here, especially here. You can't create a jagged array with an allocation like that. Okay, semicolon, call plus plus. And then we would just say tick2 subscript row in subscript, subscript call in subscript is equal to a space. Or a question mark, just to see something different, right? And it's going to offer to change this to functional. Well, okay, it's true that since we're honestly, I don't really like thinking about that working that way. I mean, I guess it would work, but I don't like using for each loops when we're changing the data because we just get a temporary variable here. And so honestly, I don't understand how this is working. Maybe I see how, because it's a reference to a reference. Yeah, that would actually work. In which case we could make this one a for each loop as well. Well, fine, if we're going to write it as a for each loop, let's do that. So for every string array row in the tick2 array, but see, that's where it breaks down. We have a reference to the row, so that's okay. But after that, we cannot use a for each loop inside it. I wish I just left it the way it was. I'm going to undo this quite a few times and not fuss with it because I think it's understandable. Nested loop, you use two variables. One of them is row, the other is column. And then you access it by subscript row, subscript column. And let's print it out. Now for printing purposes, for each loops are just fine. We could print it like this, right? And just replace this with a print statement. System.out.print the item at that row. So that would be tick2 subscript row subscript call. And then how about a space? Just to kind of expand it a little. All right, so when we print it out, we're going to see our 3x3 grid. Except I forgot to put a print line after printing out all the elements in that column, in that row. So after we do that, got to go here, and then we need to print a line feed. System.out.println, right? And there's our 3x3 array. And let's say that we wanted to put an X in the middle. Well, what position is that? Well, if that's row 0, then that's row 1. And if that's column 0, then that's column 1. So we want to put an X into our array. We have two arrays that are identical, right? Tic-tac-toe and tick2, whatever. So tic-tac-toe, subscript 1, subscript 1. No, this is the one that we filled with dots. So why don't we just use that tick2 array is equal to a capital X, all right? And then we could print it out. And this time I am going to let it make its for loop changes. Convert to a for each loop. Convert to a for each loop. Now what are you complaining about? Explicit type can be, okay, well, we'll talk about that in a minute. Alrighty. So for every single dimensional array in our double dimensional array, or we could call this like for row, for every row in our array, and then for every value in that row, print that value out. All right, let's assign another value, right? Well, if we put an X there, then let's put an O there. So what row is that? That's row 0. What column is it? Well, that's column 0, column 1, column 2. So 0, 2. So tick 2 at 0, 2 is equal to an O. And let's just copy this loop again. By the time we've done this many copies of it, we should have made it a method, right? All right. So now we're going to type in our queue to get everything rolling. And here's our array. And then we put an X in the middle. And then we put an O up in the corner. And it would have been nice if we had separated these by blank lines, right? So why don't we do that? Put that there. Put that there. Well, maybe before the assignment. There. Once more. All right, and so there's our tic-tac-toe board as it begins, and we've got an X in the middle at position 1, 1, and then we have a O over here in the corner at position 0, 2. Except not commas, I'm sorry, but it's subscript 0, subscript 2, and subscript 1, subscript 1. All right, that really is just about enough to cover. I'm not going to make an assignment because it's too late in the semester, right? But I do think you have the ideas. Do take the quiz over arrays if you haven't already taken it. And I would love to see everybody in the fall semester.